Hello, everyone. I hope you are well from wherever you're watching from. We are students from Makerere University Business School, and we are offering Business Statistics program. We are Group 1 from the evening class. My name is Hilary Kemigabo Kazora. I'm going to allow my colleagues to also introduce themselves, and then we can go on.
Hello, my name is Jamwaka Anthony.
Hello, my name is Ojula Justin.
Hello, my name is Kuniha Eugene King.
Hello, my name is Magara Francis.
Hello, my name is Mercy Nabdua.
First of all, before we even begin, we're going to be talking about statistical quality control. But before I begin, I would love to thank very much our lecturer, Professor Gideon Kurunziza, for such a great opportunity for us to be presenting this topic in production statistics. So before we go any further, I'm going to be asking a simple question. What do you think quality is? Quality in a layman's language would maybe sometimes mean would mean something that is to them, maybe something that's good or something that is to their preferences. But this is the definition of quality. So quality is the degree to which a product or service conforms to its design specifications and meets the customer requirements. So quality is not just a thing we perceive, but it is measurable. Quality is, for example, I'm going to give an example of a Coca-Cola bottle. If at any point Coca-Cola produced a 500 ml bottle and it is tagged on the bottle that it should be 500, and yet inside the liquid that is in that bottle is not 500 ml, we can say that whether the customer likes it or not, whether the taste is the best or not, by standard, it wouldn't be of quality because it is not what it says to be. Yeah, you get that? So quality is measurable. Quality is assessed through weight, through size, through reliability, durability, and safety. Yeah, so quality is also in terms of production consistency. Does your quality ensure uniform performance across all production branches? For example, if Coca-Cola today produced 500 ml bottles and they're all 500, and tomorrow it does maybe something that is different, and the other day it does something that is right. So production in terms of quality has to be consistent. It has to be something that you are doing every day. If you're saying that your bottle is 500 ml, it should be 500 ml every day. So quality also is very important. It is at the heart of production, because if your products are not of quality, then it could damage the reputation of your company. It could also cause wastage and all that, because we are going to have defects, and then we don't want your company to have that kind of wastage, because then we are making our costs of production higher than they are supposed to be. Yes, so because I want us to understand quality before we even go deeper into it, why it is important, how do we measure this quality and all that. Yeah, so I'm going to be allowing my colleagues to talk about it in depth. Eugene, you're going to be talking about statistical quality control. How is it measured scientifically? How do we say that this is actually of quality, and how do we say this is not?
Thank you, Hilary. So now we understand what quality is. So we are going to see how we control quality scientifically. Statistical quality control is an application of statistical methods to monitor, control, and systematically improve product quality in a production process. So our keyword here is systematically. We are going to see if we have any variations in our production process. The there will be no any consistent key there. So then we have our main issue, which is the variation. Then in statistical quality control, we have two types of variations. We have the common cause variation. This is the random and normal background noise in any production process. This can be eliminated and it's considered statistically stable and predictable. Our second variation is the special cause variation. This is the variation that arises from unidentifiable specific problems, which are the machine malfunction, the defect through materials, or any operating errors in the production process. If this is found in the production process, it has to be investigated and eliminated very fast. Then, and this has mathematical tools that are used to detect it in the production process. Now, we are going to see how these ideas are historically built up and who shaped them. Let me hand over the mic to Mercy to take us through them.
Thank you, Jean, for the great opportunity. It's easy to say that statistical quality control is a modern high-tech concept, but this actually comes from 100 years ago. We see statistical quality, and understanding the history helps us know why these tools are trusted today. Let us go back to the 1920s. We see Walter Shewhart. He was working at the Bell Laboratories, and he was the first who developed the control charts. And we see that upon developing the control charts, there's a telephone equipment that was being manufactured inconsistently. And he came up with a solution of trying to control the system scientifically. But then we see that his solution was plotting the chart. You draw the statistical limits, then you plot the charts, you draw the statistical limits, then the chart will tell you that something is wrong with the production process. Then from that, in the 1950s, we see W. Edward Demings, and this was after the Second World War, and the Japanese manufacturing was going into ruins. And he came to Japan and taught them the Shewhart's statistical methods, and these and the 14 famous points. And these methods helped Japan to transform in the manufacturing sector. And we see that what happened next was that Japan, in the companies of the Toyota companies, he produced. It became the world-class company, and it became the benchmark of quality to the globe. To the 1980s, we see that it wasn't just about quality control, but it further transformed to the total quality management. And the total quality management, this idea, it wasn't about the quality of company's flow problem, but then it was first published in 1987 as a global quality management statistical standard, and it belonged not only to the employees, the department, but also to the level management. As of today, we see the Six Sigma and industry. The Six Sigma, it targets fewer than 3.4 defects per million unit produced. And we see that it is a quality statistical standard with digital sensors, AI, and real-time data monitoring system. And we see that the quality of the production lines has been applied, the quality of production has been applied across all the production units. And as far as the history has come, it's not all about the trend, but it's about the refined it has been proved and tested in the manufacturing sectors, and with all that we can see that it has been used to develop the quality of production in Uganda. And we can see, and as far as we go, my colleague Jamwaka can explain more on that.
Thank you, Mercy. So when we are to talk about the quality standards, here we are going to talk about two standards. There is one, the ISO 9001, and the UNBS. So both of these, they work differently, whereby the ISO 9001 is internationally recognized, and for it certifies standards of the production process, the system, how the system measures, how the system produces the products to the final stage. Given an example for Coca-Cola, as it is, it has a production process from the point where they get the plastic bottles, they sanitize them, then they fill in the soda, to the last point of packaging. It follows a system, and that system is always documented. And such systems, they are supposed to be under the certification of the ISO 9001. So in simple terms, that ISO 9001 doesn't focus on the quality of the product inside, but it focuses on the actual system that we are used to produce a quality product. And it helps firms to export their products if they are to tap into the international markets, given they want to get extra income. For example, let's say Coca-Cola wants to export some of its products to our neighbors here at DRC, since DRC is more of a consumer country than a producing country, so they rely heavily on Uganda. So by the time Coca-Cola exports their products there, they have to be following that standard. Now, in comparison to UNBS, UNBS is a statutory company in Uganda, and for it focuses on the product quality. And how do they certify that? How do they certify the product quality? An example, let's say you have a production farm that wants to produce maize flour. Before you get that UNBS certification, of course, they will have to first come and inspect your premises, and they look out for the health hazards, and the equipment. Are the equipments to standard? Do the equipments also follow the ISO 9001 quality standards? All that. Then later on, they will pick a sample of your product and take them to their laboratories to check for different substances. Do they have the ingredients that are good for human consumption? Do they lack aflatoxins? So once you complete that and the results come out to be that you are good to go, then they'll offer you a certificate that certifies your products, meaning you can be now able to sell within here Uganda those products, and those products are good for human consumption. So I would like to give the next person, Justin.
We're going to look at how quality is measured, and you cannot measure what you do not produce, what you do not have. So we're going to look at majorly 3 methods, whereby we have the defect rate, standard deviation, and then process capability. And then when we talk about the defect rate, here it determines the amount of products that are faulty out of the total that is produced. Let's give an example. A company X, that is Coca-Cola, is producing 5,000 crates of soda, and then realize that the defect is 10,000, and then the rate is 2%. So therefore, the company, this helps us to determine whether the products are in line with the quality. I mean, the company is in line with the quality standards. You get. And then when we talk about standard deviation, here we are looking at is the production process consistent? Are you producing consistently? Like, is everything coming out well? Let's give an example. You're producing 1,000 crates of soda. Remember, when we talk about this production, when the production is large, meaning there is the production it is not consistent. When it is too large, it's heavy, meaning that the process is not moving on well. But when it is small, the production is small, the products you're producing are good, the quality is good. And then we go to the process capability. Here, under process capability, we look at how is it in line with the standards? Is the production in line with the standards? So process capability here looks at the production process. Is the production process in line with the standards of production? Here we're going to look at the specimen limits. Well, we're going to have a formula whereby the CP, that is the same as the process capability, it is equal to the upper specimen limit minus the lower specimen limit. The upper specimen limit, that is the amount you're producing. The highest amount you're producing minus the lowest. And then we're going to divide it by the 6 sigma. The sigma is the same as the variation. And then whereby we're going to give an example. When the CP is greater than 1, meaning the process is capable, meaning the production is consistent, like it's good, it meets the standards. So your products are meeting the standards. And when the CP is less, the process is not capable, meaning here we are failing. It's not good. It's not good for the company. Like the products you're producing are not in line with the standards. Therefore, you have to adjust. Let me invite the next presenter to lead us through the next presentation.
Hello everyone, welcome back. This is Magara Francis. But before this, I would like to give you a practical example. Imagine you go to a shop, then you buy a 500 ml bottle of Coca-Cola, but you find maybe it is 490 or 505 ml. Would you sue the company? Would you still trust the brand? Or let me give it to you. These companies always have a range. They can say, let us have a +5 or a -5. So meaning that if they tell you that it is a 500 ml bottle, it can either be 495 or 505, giving a range of 10, or what we call a tolerance width of 10 ml. Giving you an example, here we have a capability of, or what we call a variation of 4 ml. If we are to measure the process capability using the formula that we were given before, which is the 10 then divided by the 6 sigma, and our sigma now we are having 4, it gives us 0.42. This one is less than the capability level. Yeah, it is less than 4, meaning that this one we cannot accept it, it cannot be tolerated. So here companies come in and intervene, apply what we call SPC to by monitoring and calibrating. They deploy an X-bar control chart to track mean field volume in real time. They can calibrate the filling machine to reduce the process of variation. Also, there is another cause which may be the pressure fluctuations. You may find that the pressure which has been put in the drink, the carbonated drink, is high or it is low. So they have to come in, they investigate and eliminate all assignable causes and factors. So after the intervention, what has now come out? You may find that now that the variation has changed from 4 ml to now 1.5 ml. So if we go back to our formula and we measure or calculate, it gives us a CP of 1.11. As we go back to re-rate to to the CP level, if anything is above 1, then it is acceptable and it is in improved state. So now the process is now capable. Output is consistently within the specification, high yield, then there is less rework or less waste, and it is within the standards of UNBS. Now, coming back to our control systems in farms, we have the quality policy and objectives. These are clear written targets for acceptable defect rates, tolerances, and customer satisfactions. Take for example, UNBS can put on, like, if you are producing your Coca-Cola drink, we have this. We can tolerate this amount of CP. So these are the quality policy and objectives. Then also they have SPC, which we have used in the previous practical example. This one uses the control charts to monitor production in real time. They do detect special cause variation before large defect batches, before they do accumulate. Here the SPC help the companies to see if they are in the range or the tolerance range, so that they cannot output their products when they have defects. So that is the function of SPS, of the SPC. Also, we have employee training and preventive maintenance. Workers understand quality standards and machines that run within specification and the front line of defect prevention. Here the employees are trained the basics. They may not know all, but they are given some basics to prevent or to monitor the quality standards and do everything which lies within the quality systems. Also, we have internal audits and documentations. We have those regular audits that come to verify the procedures and make sure that they are followed consistently. Here, we bring in people from outside, because you may find that within the company, people are used to the people who are inside there. So we have to bring in outsiders who have to come to monitor and follow up everything that was put in place to follow the standards. Here, even also there is documentation which creates evidence compliance. You have to write down your quality systems, write down everything, so that even after the employees who are there, others who have come in, they have to follow that same documentation. Then also going on, we have the next one, which I think is the last one, which we call the PDCA cycle, or what we may call the continuous improvement. PDCA, someone who is there may be wondering what PDCA is. It is plan, do, check, act. So we have to make a plan. Also, you implement that plan, you check it to see if it is consistent, if it lies down within the range of the quality control systems in firms, then you put it in action. I think going on further, we can go to check what Uganda uses as its quality control in production statistics. In Uganda, we have a body which controls the production statistics, and that is none other than UBOS. You may be wondering what UBOS is. It is the Uganda Bureau of Statistics. It measures the industrial production index, which we call IPI. This industrial production index tracks changes in manufacturing volume over time. Take for example, we have UMA, we have NEC, we have all those sorts of production companies. These companies are monitored by UBOS, and UBOS comes in to check what they have produced. Are they of good quality? Are they in the range of standards or not? If they are not, then what is lacking? Then they go back to the SPC and take action. Also, UBOS, it measures the capacity utilization rates. You may find you have your company, it has a very, very big setup. It has everything, the machinery, the working people, name it. But then the production is less than the capacity. UBOS comes in and asks you what is going on, what's going wrong, where are we going wrong? It has to intervene, also puts up the measures so that the capacity that has been installed is used well, and there is no underutilization of the capacity. Also, UBOS comes in to do manufacturing output by sector. We may have food processing companies, we have beverage companies like the Inayu breweries, then we have textile like the Ginger Textiles, we have cement like the Tororo, like the Hima. So those UBOS comes in, it measures the output by each sector. How many bags of cement do you put out every day, every week, and every month, even a year? Then they have to see the consistency that you're making. Also, UBOS comes in to measure the export volumes and advise for manufactured goods. The exports, these are the goods that we put outside the country. UBOS comes in, it measures how many have you put out that is bringing in some revenue. Also, the value for those goods. Is the goods having some added value, or just produce the raw materials and you export them? That is how UBOS comes in. After that, all that what we have seen, the practical example, the Quality Management Institute in Uganda, which is UBOS, I think I can allow the moderator to come in and have a word of conclusion as we end this topic.
Thank you very much, Tim. Thank you for those very beautiful insights on statistical quality control. We now know exactly what quality is, how to measure it, the bodies that are responsible in Uganda for regulating that. As a company out there, you can use this information to build, to enhance and improve on your quality for your goods and services. Thank you very much for listening to us.